Hello and welcome to a special report from the North Pole News. I'm your host, DJ Tay, and with me I have
Spin Master Traster.
whoop whoop what? All right, so we are here for you, Tap Tigers, to discuss a very important issue. It's the Unit 3 Study Guide.
With your code information, DJ Tay is going to go over what you need to do to get credit for this assignment.
All right, so you may have received a cute little page like this that says, "What's your math elf name?" That's the codes that we are going to collect today. There are 3 different codes, and then you're going to write out what your elf name is at the bottom. If you do not turn this in, as well as do the blog check-in on my blog, you will not get credit for this assignment.
Please make sure you take care of your codes as the video goes on.
Yes. All right, so we are going to start you off with the first part of the Unit 3 Study Guide. All right, so number 1, it says combine like terms to simplify the expression. Combine like terms to simplify the expression. And with the first term, we know our first step is always to identify the terms that are alike. So the first one is 4y squared. So I'm looking and I see that plus 5y squared is a like term. And then I'm looking at plus 7y. And in my expression, I have minus 3y is a like term. And then I'm left with plus 10. Okay, so now that I have identified which ones are alike, I'm going to collect. Remember how we talked about gathering all the burgers together, all the fries together, all the drinks. This is what we're going to do. So I have 4y squared, and it tells me to add 5y squared. When I add those together, I get 9y squared. So that's going to go in my summary. Check that off. Next, I have 7y, and it tells me to subtract 3y. And when I do that math, I get 4y. So that's going in my summary. I can check those off. Excuse me. And now all I have left is plus 10 to go in my summary. So my simplified expression is 9y squared plus 4y plus 10. All right. So same thing to do for number 2. Number 2 is also asking us to simplify the expression by combining the like terms. So I'm going to give a little squiggly underline to 5x. And I see over here plus 3x is a like term. Then I have plus 2y and minus y is a like term. And remember, this minus y has that invisible 1. Okay? So now that I've identified my like terms, I'm going to collect. 5x plus 3x equals 8x. And then I have 2y minus 1y, and that gives me just 1y left. So my simplified expression is 8x plus y, or I could say plus 1y. All right, so number 3, it says look at this expression. Which statement about the expression is correct? So we're going to look at each of these and see if they're correct. The first A says the coefficient of the first term is 7. Well, my first term is 8a. The coefficient is 8, not 7. So I know that A doesn't work. Now B, the second term represents a quotient. And I know from my vocab that a quotient means division. And when I look at my second term, that's 7b. 7 and b are being multiplied, not divided, so B is wrong. Then C, the fourth term is a variable. That's 1, 2, 3, 4 terms. No, that's not a variable, that's a constant of 4. So that's wrong. And D, the third term has an exponent of 2. 1, 2, 3, third term. And look what's there, it indeed has an exponent of 2. So my answer is D. Now, number 4. Is the expression 4 times 3y plus 2 equivalent to 12y plus 2? If not, write an equivalent expression for both. All right, so in order to see whether or not these two are equivalent, I see that this is set up for the distributive property. So I am going to perform the distributive property in order to see if it gets me back to that expression over there. So that means I'm taking my 4 and I multiply it by 3y. 4 times 3y gives me 12y. And I'm adding. And then 4 times my 2. 4 times 2 gives me 8. Okay, so I see that these two expressions are equivalent, but these two expressions are not, because this is 12y plus 2. So it's asking me if they were not equivalent for me to write an equivalent expression for both. So this one, I did the equivalent expression. Now I need to factor in order to get an equivalent expression from this one. So when I'm looking at my 12y and my 2, I have to ask myself, between 12 and 2, what is the greatest common factor? And 2 is my greatest common factor. So that means that my 2 is going outside of my parentheses. So now I have to ask myself, I need to get back to 12y. What do I need to multiply by 2 to get to 12y? 2 times what is 12? 2 times 6. But I have to get to y, so that's going to be 6y. And I'm adding. And how am I getting from 2 to 2? Well, that's simple. If I multiply 2 by 1, 2 times 1 is just 2.
What property is that, DJ Tay?
Now we have the distributive property. And we could check it, can't we?
We can.
Yeah, so let's see. Let's check it and make sure that it's equivalent to what we have there. We're going to distribute the 2 to 6y, and 2 times 6y is 12y. And then we're going to distribute the 2 to 2, and 2 times 1, the 2 to 1, and 2 times 1 is 2. And boom. So now this is an equivalent expression to what we got there. So we checked it, and it's correct. Awesome. So now let's go to the next one. And this one might be a little tricky for you. You have to remember the properties of a square. So it says if one side of the square equals 2y plus 4, write an expression that represents the perimeter of the square. So I know that a perimeter means to add up all sides of this square. Or I could just take one side of it and multiply it by 4. So which way do you want to do it, DJ? Spin Master Traster?
I want to use the distributive property, so I want to multiply it by 4.
Awesome. So that means that I'm going to multiply what my side equals. That's 2y plus 4. And I'm going to multiply it by 4 sides, because we have 4 sides to a square. So, as Spin Master Traster has said, we are going to distribute. 4 times 2y is 8y. And we're adding. And then 4 times 4 is 16. So we have a simplified expression there that represents the perimeter of this square.
And that makes sense because it's groups. So if there are 4 groups of 2y plus 4, you have your 4 sides.
Absolutely. All right, so let's look at the last one on this page. It says, look at this expression. 14 plus 6 squared minus 10 divided by 2. What is the first step to simplifying the algebraic expression when applying the order of operations? So we have PEMDAS over here on the side, and that's kind of like a cheat sheet for you. So we know our first step is parentheses, and we don't have any there. So that's not a step that applies, so we can cross it off. So really, what do we have here? Our next step is exponents, and boom, we have one there. So exponents will be our first step. So in order to solve this, we would multiply 6 times 6 as our first step. Because 6 times 6 is 6 squared in expanded form. All right. So I am here to get you going for your first code.
It's code time.
All right, code time. All right, so your math elf name for code 1 is going to be, now listen carefully, the last letter of your first name. Last letter of your first name. All right, so let's look at these. So if your last letter of your first name is A, is Twinkle, B, Jiggly, C, Poppy, D, Poppy, E, Buddy, F, Thoughtful, G, Smiley, H, Cheery, I, Sweet, J, Bubbles, K, Bouncy, L, Happy, M, Sparkly, N, Playful, O, Tiny, P, Rosy, Q, Nimble, R, Mighty, S, Sassy, T, Cuddly, U, Unique, V, Jumpy, W, Quick, X, Wild, Y, Merry, and Z, Fearless. So let's see, what is your code? Let's do my code. I'm going to go by Tay. So the last letter of my name, my first name, is E. So according to our codes, that means it's Buddy. So the first part of my name is Buddy. That's my first code. And what do you have, Spin Master Traster?
Well, I too end in E, so I am also Buddy.
Boom.
That will be the first part of my math elf name.
Awesome. Awesome. Great. All right. So now we are going to get ready to start page 2 of our study guide.
All right, so page 2, we are looking at, let me zoom in a little bit. More order of operations.
What?
So we have number 7, evaluate, which means solve the expression 12 divided by the group of 8 minus 4 plus 2 plus 2 squared. So we're using our cheat sheet on the side again. We're starting with parentheses. Even inside the parentheses, we have to follow the order of operations. So I don't have anything nested inside. I don't have any exponents. I am looking at multiplication or division. I don't have any. So now I'm down to addition and subtraction. And those happen in what order, DJ Tay?
Whichever comes first.
Left.
From left to right.
That's right. So I'm doing 8 minus 4 gives me 4 plus 2, which gives me 6. I'm going to keep that in parentheses because some of us like to follow those steps. I bring down everything else from my equation, and then I am looking at my next step. I have taken care of my parentheses, so what am I doing next?
Exponents.
Exponents. So that we don't make any mistakes. In my class, we always talk about rewriting it. In this equation, yes, I know, it would still give you the right one, but we want to make sure that we're writing 2 times 2, which gives us 4. Now I have 12 divided by 6 plus 4. I have taken care of my exponent, so I'm on to multiplication and division. For this one, I do have a division, which is 12 divided by 6. So for 12 divided by 6, that's going to give me 2 plus my 4. My last step after completing multiplication and division is to add. 2 plus 4 gives me 6. Now I'm circling my final answer. So when we have done this one, we ended up with 6. All right, let's take a look at number 8. Again, we're evaluating the expression. Only 2 terms in this one. Both terms have exponents. So, do we have any parentheses?
Nope.
Nope. But we do have exponents. Exponents, just like everything else, left to right. So let's look at our first one. We have 4 to the 3rd power. Same as 4 times 4 times 4. Remember, these are multiplications. 4 times 4 gives you 16. 16 times 4 is going to give you 64. So I have 64 plus 3 squared. All right, so let's go ahead and square 3. 3 times 3 gives you 9. So I have 64 plus 9, which gives me a final answer of 73. I have taken care of my exponents, and then I finished off with addition. Didn't have any multiplication division in my line. All right, let's take a look at our next problem. We have number 9. It says, look at this expression. B plus 9y minus 11. which term in the expression has a visible means that you can see it, coefficient? I have b plus 9y. Those are the only two that have a variable. So now, does term 1 have a visible, meaning I can see it, coefficient? Nope.
Must have an invisibility cloak on.
It does have an invisibility cloak. The invisibility cloak is hiding the
1.
So the second term has a visible coefficient, which is 9. My answer is second coefficient.
Our second term.
Oh, our second term. Sorry, our second term, and the coefficient is 9. Second term, and it is 9.
9
All right,
baby.
So we have our 9 here. All right, let's take a look at number 10. Number 10, it says, look at this expression, 8x plus 7 cubed. Which of these correctly translates the expression? So we're going back to the beginning of our unit when we were using our turnarounds and our vocabulary for addition, subtraction, multiplication, and division. Has to correctly give me the translation for 8x plus 7 cubed. So let's take a look at each one. The product of 8, a product that tells me that I'm multiplying, 8 times the cube of the sum of a number and 7. So that would be some number, right? And we are cubing it. Well, if I'm cubing that number and I'm doing 8 times that doesn't look right. So that will not work. For B, the coefficient, 8 times the sum of a number and the cube of 7. 8 times the sum of a number and the cube of 7. Sum is addition. So I have 8 times n plus 7 cubed. Nope, that's not matching up, so that B is not going to work. Let's take a look at C. The sum of 8 times a number and the cube of 7. So that one's all together. 8 times a number plus the cube of 7. There we go. 8x plus 7 cubed. Well, this is looking good to me, but I want us to check D just in case. The cube of the sum of 7 plus 8 times a number. 7 cubed plus 8 times a number. Nope, that doesn't work. So my answer definitely is C. 8 times a number plus 7 cubed. All right, so let's take a look at number 11. Students were given this problem. We have D plus D plus D. Jackie argued that D plus D plus D is the same as 3D. Anita argued that D plus D plus D is equivalent to D cubed. Who is correct, and how do you know? Well, first of all, when we were talking about our exponents, we know that exponents were multiplication. And we know that when we're adding numbers, we're grouping them, we're gathering groups of them, we're collecting them like we did when we were doing our like terms. So this has 1D, 2D, 3Ds. So Jackie said that it means 3 times D. All right. Anita is arguing that D plus D plus D is D cubed. But what was the mistake on that one? What were the operations here? They were addition. What does D cubed mean that we're doing for each of them? D cubed means that we're multiplying. So, who was correct in this one?
Jackie.
Jackie is correct. And that is because she combined the like terms. You got to get used to writing in math of D plus D plus D to equal 3D. And we already said for this one, if we were doing D cubed, that would be D times D times D, which is a different operation. All right. We're on to page 3 of our study guide.
And we're coming back with some more math codes for you. So let's look at code number 2. Code number 2. This is, code number 2 is for class period and math teacher. Class period and math teacher. So if you have DJ, Tay, for first period it's exponent, second variable, third quotient, fourth distributive, fifth reciprocal. And if you have
Spin Master Traster.
whoop, 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 what?
You have first period, you are power. Second period, substitution. Third period, difference. Fourth period, associative. And fifth period, simplify.
Awesome.
So, DJ Tay, what is your second name?
Let's
What period are you
see.
going to go with?
I think I did second the last time. So I'm going to give a shout out to my third period today.
Third period.
Yes.
All right.
So how about you, Spin Master Traster?
I am going to give out a shout. I'll stick with you. I'm going to give out a shout out to my third period as well.
Awesome.
Third period.
So we are writing in our we're writing in our second codes. So mine is quotient.
And mine is difference. So I am Buddy Difference.
And I am Buddy Quotient.
Buddy
Woo,
Quotient.
woo.
I like it. All right.
All right, awesome. So now we are getting ready for our next page, our third page of our study guide.
Thank you.
All right, so number 12 says, write the algebraic expression that represents this. 2 more than 7 times the sum of w squared and 4. So, that's a lot. That's a lot in there.
Yeah, let's break it up.
So let's break it up. So I like where it says sum. That's telling me that I'm adding something, and it says sum of. So this means this is what I'm adding. So it's telling me I'm going to add w squared and 4. So I have that. And now when I back up, it says 7 times that sum. So, I have a 7 out there. And then it tells me 2 more than all of that. So, remember, more than was a switch word. Yep. So, I'm adding my 2. And that's my final expression. All right, so let's look at number 13. What is the value of the expression? And it gives me some things to do here, and that's why we have our cheat sheet there. All right, so inside the parentheses is first. We have some things to do. We have to follow PEMDAS inside of there. So we have exponents first. And we have 2 to the 4th power. So you have to write that out in expanded form so that you can ensure you are not calculating it wrong. So 2 to the 4th power equals, if you say 2 times 2, that's 4 times 2, that's 8 times 2, that's 16. So now my expression is inside the parentheses is 16 minus 7. And I'm bringing down all the rest of my expression. But I'm not done with parentheses yet. So 16 minus 7, that gives me 9. And I'm again bringing down all the rest of my expression. So now I'm done solving things inside of parentheses. And I've already completed exponents that were inside of there. Now I'm with multiplication and division. And I do have a multiplication problem here. 4 times 9, that gives me 36. Bringing down the rest of my expression. I'm done with multiplication or division. Now I'm down to addition or subtraction. 36 plus 12 equals 48. And I am done there.
Do you remember when they thought order of operations was hard?
Yeah, they did.
They've
but
come
it's
so
super,
far.
it's
Come so
super
far.
easy.
All
Just follow the steps, people. All right, so number 14, Tay, what was asked to combine like terms in the expression 6k plus 2 minus 3k plus 6 plus 4k squared. She came up with the answer 4k plus 9k plus 8. What was Tay's mistake? I'm going to let Mrs. Traster, what was Tay's mistake here? Do you see a mistake?
I do. I know. This is not your normal. But your mistake was adding the 3K to the 6K to get 9K.
Well,
Yeah.
because I'm
What
supposed
did
to
we have to
grab
Yes.
that, and it tells me, boom, right there, that I should have been subtracting. So let's look at this. I have 6k plus 2 minus 3k plus 6 plus 4k squared. So my 6k has a like term of subtracting 3k. That gives me 3k. And now I have 2 plus my 6. That gives me 8. And then I just have 4k squared that's left. So my simplified answer would be 3k plus 8 plus 4k squared. All right, awesome.
All right, number 15.
Look at the expression. Which variable has a coefficient of 1? Coefficient of 1.
It's the invisibility cloak.
Can you see it? No. You can see it? No.
Dancing.
Woo,
okay,
woo.
we're dancing.
All right. So the variable with the invisible one is, drum roll please, D.
There it is.
Because we see this has a coefficient of 9, S has a coefficient of 5, and R has a coefficient of 3. So D has a coefficient of 1. All right. Number 16, when x equals 3, what is the value of this expression? So this is substitution. After we substitute, we're going to follow our order of operation. So here we have 4x squared minus 6. And we are going to substitute in our, wherever we have x, we are going to put our 3. Okay, so now I have to follow the order of operations. I don't have anything inside the parentheses to solve, so I'm done with that. But I do have an exponent, 3 squared. So that means 3 times 3. That gives me 9. All right, and this is still being multiplied by that 4, and then subtract 6. Well, now 4 times 9 gives me what? 36. And I'm taking away 6. So 36 minus 6 equals 30. All right. Last one on this page. Look at this expression, 25x plus 15y. Write an equivalent expression that uses the distributive property.
Ooh, I love the distributive property.
Yes. So we are factoring again here. All right. So we're looking at these two numbers, 25 and 15, and we have to think, what is the greatest common factor? Greatest common factor.
They could use one of their old strategies.
Ooh, what can I use?
The ladder.
Ooh, the ladder method. Yeah, so if you need it, use the ladder method. All right. So I can look at these two numbers and I know that they share a 5. So that means that's going on the outside of my parentheses. So now I'm looking, in order to get to 25x, what do I need to do to get there from multiplying by 5? Well, 5 times 5 equals 25, and if I have an x there, 5 times 5x equals 25x. And I'm adding, and now I have 15y. How am I jumping from 5 to 15? I'm multiplying by 3. And it's a y here, so 3y. But I'm not done yet, because I like to make sure I have everything correct. So I'm going to use the distributive property just to check to make sure. So 5 times 5x is 25x. And then I'm adding. And 5 times 3y is 15y. And boom, I'm right back where I need to be.
I like it. All right, our next and final page. We're at question number 18. For this one, we have which expression, I'm lost up here. Which expression is equivalent to 60x plus 6? So we have two different problems that we have to sort out. We are going to apply the distributive property to both of these. So I have 3 times 20x. 3 times 20x is going to give me 60x. And then 3 times plus 2, or 3, keep the sign, times 2 gives me 6. So I have 60x plus 6. Well, that one's looking pretty good. Let's take a look at our next one. We have 2x times 30. That gives me 60x. And then I'm multiplying 2x times 3, which then gives me 6x. Well, when we take a look at this, we notice that there's an additional variable on the end. So this one will not be equivalent. A is our answer. Let's take a look at number 19. So for number 19, we have Matilda makes cupcakes to sell at her friend's lemonade stand. She sold 36 cupcakes and sold them for $2 each. Write a number sentence using the variable m to represent the total amount of money that she made. So I have 36 cupcakes, and each of those cupcakes, she's selling them for $2 a piece. Well, in order to find out, I'm doing the total that she sold times $2, and that will give me the money that she's made. It's just 36 times 2 equals M. If we have number 20, evaluate, solve for this expression. We have 24 minus 15 squared. Again, we're using our cheat sheet. I have parentheses first. 24 minus 15, this is going to give me 9, and then I have 9 squared. So I have taken care of what's inside of the parentheses. Now I have to use my exponent. 9 squared, 9 times 9, which gives me, that's right, 81. Exponent is finished. We don't have to worry about multiplication, division, or adding or subtraction. Awesome. Our last section. So our last section is a little bit of a short answer. Before you start writing out words everywhere, let's make sure we read the directions. It says write an example of each algebraic property in use. So our first one is commutative property. And when we have been talking in class about commutative property, the biggest point that we have made is that the numbers are changing in order, but the product or the sum is going to stay the same. So let's do, yours may look different than mine.
And it should.
It should. If I have 4 times 8, the commutative property tells me I can do 8 times 4, and it's still going to give me the same thing. That's for multiplication. For addition, let's say I do 6 plus 7. Well, 6 plus 7 is going to be the same as 7 plus 6. You should not be using my examples. You need to come up with 2 on your own. 1 for multiplication, 1 for addition, please. Identity properties. For this one, if we are keeping our identity, we don't want to change. Don't go changing. So, okay. We have 9 times 1. This Traster's a little crazy at the end of the day. 9 times 1, that's going to give me 9. Because if I want to keep 9, the only way I can do that is by multiplying it by 1. And then for addition, if I want to stay at 2, I don't want to change my identity, I want to equal 2, what can I add to 2? I can add 0. So that is our identity property. Associative property. If I have 4 plus 5 plus 6, and I group the 5 and the 6 together, I can still add 4 plus 5 plus 6 and group 4 and 5 together this time, and that will give me the same. And for multiplication, if I have 2 times 3 times 1, I can multiply and group them with my 2 and my 3. I can switch it to those. So make sure you're grouping them up. All right, here comes your last code, guys.
Last code. All right, so your math elf name, first letter of your last name. We have A for peppermint, B sugar plum, C cocoa, D tinsel, E cookie, F tootsie, G spearmint, H pudding, I pine, J peaches, K angel, L pie, M cinnamon, N honey bun, O marshmallow, P sugar, Q nimble, R cupcake, S cake, T frosting, U unique, V snowflake, W eggnog, X sprinkles, Y bubblegum, and Z candy cane. So what is your final one, Mrs. Traster?
Spin Master Traster can also be known as Buddy Difference Frosting.
Nice.
How about you, Miss Tay?
All
DJ
right,
Tay?
DJ Tay. Okay, so I am Pew. So my last one is sugar. Buddy quotient sugar.
Buddy quotient sugar. You are
so sweet.
I love it. All right. Let's flip this back up here before our video ends. Let me flip us so that we're not upside down. Okay, there we are. All right, guys. We hope that this has been very helpful for you. Your Unit 3 test is scheduled for
Thursday.
Don't forget it. Make sure you get your USA test prep done. Bring in any questions you have.
Bye.